We're going to graph some square root functions without using a graphing calculator. I'm going to start with the parent function, which is simply square root of x. The best way to do this is to make an xy table, or a table of values. So I am going to set one up here, and the starting place for it is where we take the inside, the radicand. It's inside the radical. You take the x, whatever it is, and you make it equal to 0. Now, actually, the best thing to do is to make it greater than or equal to 0, because that's also your domain. But when you make it equal, then the number you have is the starting point here on this. It's not always the starting point. Remember that. Don't get used to using 0 every time. Make sure you base it on whatever's inside here. So when we do the next example after this, it will not be 0 that's here. But what we're going to do now is put 0 in here and do the square root of 0 and get the y value for it. Because the function of x, or the result of using the x, is going to be the y value, and that gives us 0. So over here on the graph, that's going to be our starting point. Our next one is we're going to put in the number 1, so we'll move up from 0. Square root of 1 is a 1. And then I can put square root of 2 and get 1.4 something, but I can put any number I want to. So I'm going to put numbers that are easy to work with, because if I do the square root of 4, that gives me back a 2. And if I do 9 to have the square root of 9, I get back a 3. Those are enough points to graph this with. So over here now, on the graph, we have 0, 0, 1, 1, 4 and 2, 9 and 3. That gives us this kind of a curved graph that will go forever and forever, slowly moving up, but very slowly. This is what a square root function always looks like. It might be varied in some form, which we'll see with a couple of the other ones we do, but this is the basic square root function. And graphing it like this gives you the points that you can use to do it. Now, we also have to determine the domain. The domain are the x's that are used in this graph. And visually we can see that starting at 0 and going to all the numbers greater than 0, those numbers are used in this graph. The negative x's are not. Therefore, the domain is that x is greater than or equal to 0. Notice that that's the same as what we get up here. When you take what's inside here and you make it greater than or equal to 0, you have your domain. Next is the range. The concept for the range is exactly the same, but now it's going to be with the y values. And when you look at it, you see that all the y values that are 0 and above are going to ultimately be used here, because that graph, after many, many miles, will get up to 100 or 10 or 1,000 or whatever here. But every y value will be used. So it'll go up to positive infinity, and this will go to positive infinity. So you can show that y is greater than or equal to 0. And therein now we have the domain and the range based upon the graph, and the domain also based here on the radicand. Now let us look at a second example. In this case, it's going to move around a bit. So there are variations here, and we're going to do it though the same way. First, we're going to determine where the starting point is. We're going to take the inside, the radicand. This is not inside it, so we don't use it, but this is, so we use that. And we make it greater than or equal to 0, and we solve for x. So x is greater than or equal to -2. The equal part means that this is the starting point. So we'll do the table of values, and you put -2 as your starting number. When you put a -2 in here, you get a 0, and the square root of 0 is 0, and 0 plus 3 means that you have a 3 here. Normal things you've been doing with tables of values for many years. This is a perfect place to use it. In fact, it is the best way to do it if you are not using a graphing calculator. In fact, you don't always need a table of value. You can start here, and then you can figure out in other ways where you're going to be doing the graph. But it's much better to put a few points and then connect the dots. So we'll go up from -2. Oops, I did it to -3 here. So it's -2 and a +3. Let's be more careful. X -2 and then a y of 3. So it looks like we are here at this point for the starting point. All right, so we are going to put -1 as the next number to use. -1 plus 2 is a positive 1. Square root of 1 is 1. 1 plus 3 is 4. Now, I want to choose the numbers carefully so I get nice, easy square roots to use. So 0, 1, the next perfect square is a 4. To get a 4 in here, x would have to be 2. So if I use 2, 2 plus 2 is 4. Square root of 4 is 2. Oops, I forgot to add the 3. And it's a good thing I noticed it. This is common. It's common to forget one other part of it, but make sure you think about it so you can go and fix something like I did here. Next, I want to get a 9 here because the square root of 9 would be 3. That means the x would have to be a 7. So 7 plus 2 is 9. Square root of 9 is 3. 3 plus 3 is 6. I have enough points to work with now. I already have the -2, 3. Now I'm going to do -1, 4. 2 and 5, and 7 and 6, 3, 4, 5, 6. Notice that the curve is pretty much the same as the kind of curve that this one had. I need to make it at least a little more curvier there. I started off not curving a little too much, but you get the idea. You can see it. So you see the starting point is here. That means that all of these x's are part of this, which means from -2 on, which means the domain is x's that are greater than or equal to -2. And then the range, I'll just simply look at the y-axis, and this is 3, which also happens to be that 3, so that means I'm going all the y's greater than or equal to 3. I can get these numbers from just the equation, knowing that's the opposite sign of that and greater than that, and it's this number on the outside for the range values, and it's greater than that number. Seeing it visually, graphically, really helps because I know it's all of these x's and it's all of these y's, which matches what we wrote here with the inequality signs. Here is now another example where we have a multiplier in front. Our procedure is exactly the same. It doesn't matter what's thrown at you in these, just do the same procedure. I'm going to take the x minus 1 greater than or equal to 0. I'm going to add 1 to both sides, so that means I'm going to get that x is greater than or equal to 1. I know that's the domain, but it still is imperative for me to do a table of values. I'll start with that 1. 1 minus 1 is 0. Square root of 0 is 0. 3 times 0 is 0. Now I'm going to go up 1 to, that was to make it 0. Now to make it 1, this would have to be a 2. 2 minus 1 is 1. Square root of 1 is 1. 1 times 3 is 3. Now I don't want to put a 3 in because that'll give me a decimal here, but if I put in a 5, 5 minus 1 is 4. So I'm selective with the numbers here just to make my life easier. 5 minus 1 is 4. Square root of 4 is 2. 2 times 3 is 6. Let's make it a 9 because I know square root of 9 is a 3. So in order to make it a 9, the x has to be a 10. 10 minus 1 is 9. Square root of 9 is 3. 3 times 3 is 9. I have enough things to graph with. So at 1, 0, 2, 3, 5, let's see, that's 2, 3, 4, here's 5. At 5 I'm going, so maybe that's 5 here. So 5, 6. And then I need to go out to 10, which is here. And let's see, 6, 7, 8, 9, 10. So here's 10 for that part of the graph. Now I want 10 and 9. So it looks like I'm at that point. So my curve is this way. That's a better curve than the last one I'm doing, so good. Notice I'm always putting an arrow here. I cannot put an arrow here because this is a starting point. It doesn't go like this any further because these x values would give you a negative inside the square root, which is not a real number. So it starts here and goes that way only. No arrows going the other way. Same thing for these. If you notice, that's what I did on this graph. I only did an arrow where it was still going, but definitely not this way because it can't go past 0. And the same here because it cannot go past -2. All right, so you just saw how what that 3 does is it expands this, I guess you could say, because here's the parent function, and here's the one where, because of what we did, we moved it over 1, but we also stretched it up like that. Now let's take a look at this. This one has a negative there now, and the number on the outside. So we're going to do the same thing. What's inside it, greater than or equal to 0. We don't have to add or subtract something, so we know we're going to be having the domain greater than 0 and equal to. I'm going to do the table of values, and I'll start with that 0. So 0, negative 0 is 0, plus 2 is 2. Now, when I put a 1 in here, square root of 1 is 1. Negative, because remember, that's a negative 1 in front. So negative 1 times 1 is a negative 1 plus 2 gives me a 1. I'm going to put a perfect square in here to make it easier. That means the square root of 4 is 2. Negative 2 plus 2 is a 0. I'm going to put a 9 in here and get another number there. Square root of 9 is 3. Negative 3 plus 2 is a negative 1. Let's graph these. So 0 and 2, 1 and 1, 4 and 0, 1, 2, 3, 4, and 9 and negative 1. All right, let's connect the dots on a nice little curve. Sort of. Gives the idea where we're going. No arrow here, so it's starting here and going this way. What happened here is that negative flipped it. This would have been going this way. What the negative sign does, it flips it over the, not the x-axis, but over the axis from where you're starting at. So it would have been going that way, and instead it flips over this way. So that's what the negative is causing in this. Rather than having to figure that out, do a table of values with 4 points, and you are pretty much assured of getting in the right place, and that's where this is. Now let's look at the domain and the range, because for each one of these, let's go back actually, let's do it for both of these, because I didn't figure out the domain for this one, but that was easy. It's x's are 1 and greater. X greater than or equal to 1, and we'll use a set notation there. And then for the range, well, it looks like zeros on the y-axis and up. So its y's are greater than or equal to 0. So really, look at the domain and range. It's the starting point, the x and the y, because all the y's are greater than that, all the x's are greater than that. Over here, it's a little different, but it's the same concept. It'll be 0 and 2, but what's happening, the x's are all the x's, so it definitely is all the x's that are greater than or equal to 0. But for the range, we started at 2, but now it's all going down. So it's 1, 0, a negative 1/2, negative 3/4, negative 5 million. It's all the y's that are less than 2. So now we have to make sure we say less than or equal to 2 for the range. That's how you determine the domain and the range, and how you graph these. So what we have looked at here is graphing the parent function using the basic thing of what's inside there greater than or equal to 0, and the equal part gives you your starting x. Figure out from the table of values some points and graph it based on that. The domain is based on the x's that are used in the graph, and the range are the y's that are used in the graph. This one's the same idea, different number results, but the same look and feel and shape of it, and the same methods. Find that, do this, set it up, and find that. We did it with this one, where it's goes up a lot faster each time because of that 3, but it's still the same idea to make the table of values after getting the starting x value and finding the domain and range. And this doesn't throw anybody off either, just when you use the table of values, it forces you to get it in the right place. And you find the domain with the x's that are allowed, and the range with the y's that are allowed.